Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to talk about reaches and routing. No reservoirs, just keep it simple. The difference between exercises and lessons is that lessons focuses on one specific topic and goes into detail, but doesn't actually build anything out. Exercises will go into less detail, but will actually start from scratch and then build something. So in the exercises, they're going to be a little bit longer, but there will be less explanation about exactly what's happening. So if you need the details, check out the lessons. The exercises are going to be more about building with a little bit less narration, but I'll do my best to add some narration to describe what I'm doing along the way. Okay, with that being said, let's get into it. Just as a quick introduction, I'm using ResSim version 3.3 on a Windows 11 operating system. Hopefully, your version will work just like mine. All right, so let's go ahead and get started. So I'm starting from scratch. I've got ResSim open up here. If you don't have the ResSim downloaded and installed, check out lesson one. That'll get you this far. And let's begin by going File and then New Watershed. By the way, you have to put your watershed setup as the selected module. So go file new watershed. We're going to go ahead and call it the name of the watershed. I'm going to call it video one, and then select your location. Just whatever directory you want this watershed to be saved to, units, and then your time zone. Okay, apply. Okay, 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 okay. So we're ready to go. I'm going to select my Uh, I'm going to actually resize my window a little bit here. Okay. And yes, stream alignment tool, hold down control, single left click, continue holding down control. I'm just going to sketch this out. Let go of control, last click, stream one. I'm going to be very generic in my nomenclature here. Computation point. Also, when you sketch out the stream alignment, make sure to go upstream to downstream. So the stationing 0 is right down here. And then computation point, hold down control, single left click on the stream alignment. I'm just going to call it CP1. Okay. And then again, hold down control, left click. I'll call that CP2. That's my downstream computation point. Watershed configuration new. I'm just going to call this config one with a 1 hour time step that's not even used. Click apply. I'm not going to fill out all this information. We're not even going to add a reservoir. So that's good. File, save watershed. Okay, ready to move on to the reservoir network. I've got to first bring in my network. So network new. There we go. Just going to give it a name. Network one is fine. We'll select configuration one and then new. Okay, so that's good. Now we'll select the reach tool, hold down control, single left click, let go control, single left click on the downstream junction. And I'll just accept the CP1 to CP2, the default reach name as is, click OK. And we now have a connected network. I'm going to go ahead and click network save. I'm going to check the routing real quick. Okay, so it's null routing. That's what we want for our default. And then I'm going to add an inflow to this CP1 junction. This is my upstream junction. And I'm going to go with click local inflow on this top line. I'm just going to say inflow at CP1 with a factor of 1. So it just multiplies by 1 and then click apply and then OK. One thing to mention on this local flow is you have to put it in the very first line. If you put it in the bottom second line, I don't think it works. So make sure you're at the very top line. Network save. Let's go ahead and make an alternative. So alternative edit and then alternative new. I'll just call it alt underscore one using network one. That's good. Now we have all this data to fill out, but it's actually very basic because the network is so incredibly simple. I'm just going to go with a time step of 1 hour. We'll say period determined, even though instantaneous would probably be used. We don't need this standard operation. There's no operation set. There's no look back. The time series is what we have to compute here, our input. So we have to identify the DSS path for this time series. So let me go ahead and do that. what I want to do is select the file, which I have prepared. So 1 second. Since I said I'm doing this from scratch, I really will. I'm going to open up DSS View. This is a separate HEC program. So let me close this real quick. This is DSS View. It's version 3.3.29. And what I'm going to do is, first of all, create a DSS file. So where I want to put that is in the same directory as my video file, my Watershed. So I'm going to put it, I'll just put it in here somewhere. These are all the files for my Watershed. Let's go ahead and do that now. File, new. I like version 6 has worked for me, and version 7 hasn't. I'm not sure why, but I'm just going to go with version 6. Okay, so let's go ahead and navigate to that directory. I believe this is it. Yes. So I'm already there. I'll call it time series data and then create. Okay, file's been created. Now I'm going to data entry, manually enter a inflow which is a time series data set. So hang with me here and just type some stuff in. Okay, so I have my path name parts up here. It built the path name below. And then I'm going to say this is for the month of June 2024. And then start time would be the first hour of the month. CFS is the units, and then the type would be instantaneous value. Okay, so I'm going to go ahead and paste my values in here, or I could type them in, but I have them prepared over in Excel. So 1 second, and then right click paste. Okay, that looks good. Let me just check the bottom. Okay, that's good. And then save. Don't need to do that. So if we want to check out what that hydrograph looks like, here it is. It's a base flow of 5,000 CFS, and then after about like 4 or 5 days, it peaks up to just above 30,000 CFS, and then it comes back down, and then it's just constant again. Right. So that's the time series data set that that's going to serve as inflow to the upstream junction. All right. So I'm headed back over to ResSim, and now I'm going to navigate to that .dss file. I'm going to open it up. Here's time series.dss. Okay. Here is the data set we just created. So when I click this set path name, it'll pop in place here. There it is. Okay. Alternative and save. I'm going to go and close that. Now let's head over to the simulation tab. Simulation new. Give it a name, simulation 1. And then this is going to be for the month of June because it's going to be the same time period as the data set that I just created. The start will be, let's start it on the 3rd. We'll start it at noon. That's what 1200 hours represents. It'll end, let's say 10 days later on the 13th. And then the look back period will start on June 1. Okay, we'll select alternative 1 and click OK. So that has created our simulation. Let's go ahead and run that simulation. Okay, it looks like it worked. And now I'm going to zoom in here and then peek at the plot for the results. And it looks basically the same thing as our inflow hydrograph. Here's the inflow hydrograph at CP1, the upstream junction. And then in green here is the flow through the reach, which, as you may imagine, is the same thing because we're using null routing. Okay, so what I want to do in this exercise is introduce a few different routing methods and see how that changes the shape of the hydrograph through this reach. So it's pretty straightforward, no reservoirs, no zones, no rules, just routing and looking at the system and the results. All right, so what I'm going to do here, I'm staying in the simulation module. I'm going to right click on our alternative 1 and then say add trial. So I'm going to give this trial a name. This is sort of a what if scenario testing. It's going to make a copy of alternative 1 and then allow me to make modifications to the trial such that they differ slightly from alternative 1. Then rerun the computation and then look at the results and how they compare. Let's just call it M for Muskingum. That's fine for now. So I'll go ahead and click OK. Here's my trial 1, M. I'm going to right click, edit run, and I'm going to edit the reaches. So the default is null routing. I'm going to change that to Muskingum. And I'm going to just type in some numbers here. So we'll go maybe 20 hours, 0.25 is not too uncommon, and then we'll say 20 there as well. And then I'll click apply and okay. And then okay here, simulation, gonna save. Now let's go ahead and run that. Trial one, okay. And then I'm gonna peek at the plot. And now what we have here in red is the flow through the reach after applying that Muskingum routing, whereas green is our original with the null routing. All right, that looks good. Let's go ahead and do a couple more and then see how they all compare. So I'm going to select alternative one, right click, add new trial. And then what I'm going to do here is I'll call this MP and then OK. And yes, I want to save. So right click, edit run, reaches. Now instead of null routing, I'm going to go with modified poles. So let me just type in some data here. I have saved over in an Excel file. So I'm just going to paste that in. On any of these exercises, if you want to pause the video and use my exact numbers, if I'm going too fast, that's fine. Or watch it double speed because I'm sure I'm going too slow for some folks out there as well. Okay, so number of sub reaches, I'll go with 12. So I'll click apply and then OK. OK. Simulation, save. Now let's go ahead and compute that trial 2. Okay. And then let's see what the results look like. Okay, so that trial 2 is in blue. So it looks like, again, there was some noticeable attenuation and lag, definitely the lag. I can just zoom in on the plot here. The original modified poles, and then red is Muskingum. Okay, so let's go ahead and do one more. I'm going to go right click, trial, and then this is going to be, we'll just call this C. Okay, right click, edit run, reach. Now I'm going to go with the coefficient routing method. So you can read the user's manual to get a better understanding of how these routing methods work. I'm not going to talk about them in this exercise, but let me type in some coefficient values now. Let's go with a 0.1, 0.2, 0.35, 0.2, 0.1, and then 0.05. I think that adds up to 1. Apply, okay, okay, simulation, save, compute, close, and let's see what we got for a plot. And sure enough, yes, there's a very little bit of attenuation based on that coefficient routing. I definitely could have changed the numbers and got a different look to this this fourth line, which is the third trial, representing the coefficient routing method. But we have our original in green, and then we've got Muskingum, modified poles, and lastly, the coefficient method. So that's it for this exercise. There's a lot more I could do. I could clean up the plot, of course. I don't like having a messy legend. I'd rather like actually label the legend with the name of the routing method. Also, I would probably want to tabulate that data and probably remove the computation point time series, but keep the flow through each of the reaches time series. Maybe export that to Excel. That's a little bit beyond what I want to do for this exercise. This is all I wanted to do was create this reach and then go ahead and create the plots, demonstrating some of the routing methods in HEC ResSim.